this lecture, we are going to present and deepen the topic of production costs, which, in conjunction with logistic costs, represent the main cost item to be considered when making any operations management decision. There are several categorization schemes and literature when treating production costs. The most used ones are by nature or by decision. Let's start by introducing the categorization scheme by nature. According to this approach, costs are categorized depending on the type of consumer resource, that is, depending on the type of production factor used. According to the classical theory, production factors are materials, labor, capital, and energy. This categorization is mostly used for internal accounting and in order to allocate cost, for instance, for price determination and for process optimization. Costs can be arranged into direct and indirect cost or into fixed and variable cost. For instance, indirect costs refer to all those cost items that are not directly related to the production of a very specific product, but in general to the production process itself. While we call direct cost the opposite situation, in which a cost can be directly related to the production of a specific product. With regard to fixed and variable cost, we use this distinction to point out whether a cost item is varying depending on a given variation of the production volume. In order to clarify these items, let's make an example by considering, for instance, a small increase in production volume. Let's assume a 10% starting next week. Let's start by considering this illustration, which is focused on materials and labor cost. In the upper part of the picture, we see fixed cost related to the above-mentioned decision. In particular, if we consider fixed direct labor cost, we have fixed operators hired by the company, while if we move to indirect labor cost, we could be, for instance, analyzing the maintenance team, which is not modified by increasing for that very small amount of volume the production. If we consider material fixed indirect costs, we may, for instance, take into consideration consumables material that are usually used for the plant startup activities, while in reality direct fixed material are usually very hard to find. If we move to variable cost, labor and direct, we basically have here temporary workers or overtime of the workers that have been pursuing the activity. While if we go to indirect labor variable cost, we may be considering, for instance, the extra time of the foreman. Moving to materials, variable direct materials are usually the raw materials consumed for production, while indirect materials may be consumable or maintenance fluid used by the plant, which consumption is modified given the increase in production level. When considering capital and energy costs, for the sake of convenience, we may focus, for instance, on the cost of dyes, which are basically direct costs since they are directly related to the product. If we are considering a very long life dyes, which is, for instance, printing a million and million of pieces, then this type of cost could be easily considered as fixed with respect to a very small increase in the production volume. While if the dye has a very short life and has to be substituted or revamped very often, then even the cost of the dye could be considered variable with respect to the increase of 10% in production volume. When it comes to energy, for instance, we can consider the production site lining as a fixed indirect energy cost, while, for instance, the production line power consumption could be considered as a variable indirect energy cost, because, for instance, the production line power consumption could be modified by the increase in the production volume. Let's now tackle the second categorization scheme, that is the classification by decision. According to this approach, costs are categorized depending on the fact that they are relevant or not when making a specific production management decision. Example of such decisions may be whether to produce or not, or what could be the optimal production batch quantity, or whether we have to perform a changeover, that is a setup or not, or whether we have to invest on an additional quality check or not. When adopting this perspective, only those costs that are relevant to that decision should be considered. But what is a relevant cost? A relevant cost is a cost item that is satisfying the following three conditions. First of all, it has to be a future cost. That is, the related cash flow should not be positioned in the past. For instance, the cost related to the purchasing of the production plant is usually a sunk cost and therefore should not be considered as a relevant one. The second criteria is that the cost should be avoidable. That is, the related cash flow should be strictly depending on the decisions we are making. For instance, the CEO wage is not probably depending on our decision about increasing or decreasing production volume, therefore it is not avoidable. Lastly, a relevant cost should be differential, which is, for the sake of simplicity, it should be different depending on the alternatives that are under evaluation. For instance, if we are checking a production plan in alternative to a new one, and if both the plants are using the same amount of raw materials, then raw materials could be considered not relevant because they are not differential. Let's make some practice with the categorization by decision. For instance, let's tackle the setup cost. A setup cost incurs any time a product entering the production process and the production line is very different from the previous one. This difference could be, for instance, in the production cycle parameters or in some specific treatment that the product has to undergo. For instance, if a black bicycle is followed by a white bicycle, a long cleaning of the painting plant has to be performed. Another cause for incurring in a setup cost could be, for instance, a big change in the production rate of the machine. And this is true especially in the process industry. The setup cost has two components. The first component is basically represented by monetary costs, such as materials consumed during the setting up, or the requirement for a specialized operation team, or extra scraps that are generated during the tuning of the machine. The second component is represented by opportunity cost, because, for instance, the time spent during the changeover cannot be used for the production activity. How can we evaluate the opportunity cost? Let's consider, for instance, the workload of the machine on the one hand, and on the other hand, what is the way to recover the production loss. If the production machine is not 100% utilized in regular time, in this situation, no opportunity cost is risen. Otherwise, if the production machine is 100% utilized, then the setup activity is basically cannibalizing production capacity, and therefore some production loss occurs. In this case, I can recover the lost production quantity, for instance, by resorting to overtime, and in this case, the setup opportunity cost is represented by the extra cost due to the overtime hours, or I can resort to sub-suppliers, and in this case, the setup opportunity cost is represented by the extra costs due to outsourcing, or there could be no way of recovering such production volume loss. In this last case, the opportunity cost is represented by the lost contribution margin of the quantity that could not be produced. Another example of classification by decision is represented by the quality cost. In this case, the focal decision is about the process capability. In order to improve process capability, a company could be investing in the quality assurance process, which is activities connected to suppliers' qualification, process engineering, testing, procedures definition, and training of operators. Once a given process capability is achieved, then the company could be deciding to perform some quality checks. And thanks to these quality checks, defects are internally highlighted. The quality check is consuming resources in terms of workforce, dedicated equipment, and space, and the internal defects are costing to the company in terms of wasted resources, management, reworks. All those defects that are not spotted internally will eventually become external defects, and in this case, we could have very costly situation depending on the cost of warranty, logistics, penalties, again duplicated activities, not to mention the loss of reputation. So by combining all of these costs, we get a thorough representation of the quality situation of the company. By increasing the investments in quality programs, of course, the quality assurance costs are increasing, but in turn this will lead to a reduction of the need of extra quality checks, as well as to a reduction of defects, both internal and external. Combining all of these costs, we get the total quality cost, which can then be easily optimized by finding the right value of investments in quality programs.